computing, and we have seen a lot of basic terms associated with the cloud computing. Especially, we have discussed the block one. Now, today we have discussed with the block two. So, in the block two for the MCS 227, that is the cloud computing, the IoT, the block two basically having the four units here, and we can see that in the block two we have a unit 4, unit 5 is discussing about the scaling, unit 6 is discussing about the scaling, unit 7 is discussing about the networking, unit 8 is discussing about the security, and unit 9 is provisioning. So let us start with the unit 4 here. So unit 4 basically discuss about the resource pooling and the provisioning. So we need to understand that what is the resource pooling and what is the meaning of the resource provisioning. So pooling means a simple word, a simple meaning of the pooling means you have to pool something whenever you require something more. So just like that, in the case of the cloud computing, resource pooling basically resource pool is basically a collection of the resources available for allocation to the user. So whenever the user wish to join the cloud service provider, so user have to declare that what kind of the resources it required, and accordingly the cloud service provider will look into their resource pool that the demanded resource are available or not. If it is available, it can be granted, and and the process execution may start. So that will become the, and that is the concept of the resource pooling. So the resource we have seen in the case of the cloud computing, resource may be any kind of the things, either it is a physical item or the virtual item. So in the case of the physical item, the types of the resources may be your compute, maybe your network, or the storage space, etc. In the case of the virtual item, we have seen about the resource may be your software, resource may be any kind of the services. So large pool of the physical resources is maintained in the cloud data center and presented to the user as a virtual service. So any resource from this pool may be allocated to the particular users. So for creating the resource pool, providers need to set up a strategy for categorizing and the management of the resources, and consumer have no control or the knowledge about the actual location where the physical resources are available. We have seen, we have discussed yesterday that as a customer, you will never be know that where is the physical location of the resource, where is the physical location of the data center, or the where is the physical location of the hardware or the software of the cloud service provider. You will never know about that one. So just like that way, so these physical resources or the location of the physical resources, it is not clear to the user. You will get that kind of the resources only. So you can see here that we have a physical resources by the help of the virtualization software. We have seen about what is the virtualization yesterday. With the help of the virtualization software, a replica of these physical resources as a virtual resources we can see here. So if suppose that I have 100 TB of the storage space, 100 TB of the storage space. So this 100 TB, suppose that this is a single storage space, single hard disk having the capacity of the 100 TB, the storage space. This can be divided into the thousand number of the small block and a small block. So this will become a virtual resources. So I have taken 100 TB of the hard disk storage space. I have virtually partitioned and created different partitions here, and one partition is being allocated to the one particular user. So in this way, pooling of the physical resource and the virtual resources is being met here. So now come to the resource pooling. So we have a shared infrastructure. Shared infrastructure means the one particular device can be shared, one particular resource can be shared by the multiple number of the user. As well as we have a concept of the multi-tenancy. Multi-tenancy means multiple users or organization can utilize the same physical resources simultaneously, while their data and the application remain logically isolated and the secure. Just like that, in the above example, we have seen that I have as a cloud service provider, I have of the hard disk. However, I have partitioned this 100 TB of the hard disk into the equal size of partitions. Suppose that 1000 number of the partition I have created. It may be equal or it may be not equal, depend upon what kind of the policy your organization allows to. So 1000 partitions I have, and this among these 1000 partition, I am presently using. So these 10 users will work in their own partition area. They cannot look into the other partition area. So whatever the storage boundaries are given, storage space are given, the customer need to stay in their particular space, and they may do whatever the operation they are doing, that will remain in their partition area only. It cannot be so it is logically isolated, not a physically isolated, as well as it is secured by the means of some boundary concept. We are securing that no other users may jump into the this particular shared resource area. Just a minute. So this we have seen about the multi-tenancy concept here. Similarly, we have another features like on-demand self-service. On-demand self-service. Suppose that during the execution of your program, during the execution of your task, you need some more resources. So that can also be provided to you. So self-service aspect means you are without being interacted with any particular person on other side, the cloud service provider. You are not talking with any person. You are talking with some kind of the robots, and that robots identify your needs. It give you the some of the option. You are selecting the one particular option, and accordingly it proceed in the phase by phase basis, and the resource is being allocated. So on-demand self-service, you already have some set of instruction. You need to follow the set of instruction, and the resource will be allocated. Elasticity, so pooling also support the elasticity and allow users to scale their resources up or down dynamically during the uh, during the execution of the program. So scalability or the elasticity means you suppose that during the execution of the program, you suppose that you need two number of the more resources. So it may be allocated to you if the two number of more resources, the replica of the resources are available. Similarly, during in the initial phase, you may have given the 10 number of the resources, and during after half an hour of the work or after 1 hour of the work, it has been observed that you are only using the two number of the resources. You have been provided 10 number of the resources, however, you are using only the two number of the resources. So the rest eight number of the resources may be deallocated or not the eight. Suppose that five or six number of the resources will be deallocated to you, and it may be given to the someone else customer. Once you will utilize all your resources, then the next the replica of the resources will give it. So that is the elasticity means we are scaling up, scaling down the requirement and the availability of the resources as per the demand. Similarly, the virtualization takes the very crucial role here, and the resource pooling by abstracting physical resources and creating virtual instances, allocation and managements are being done by the virtualization software. We have seen about the virtualization software yesterday, that we have a various kind of the virtualization software, and that particular virtualization software basically deals with the allocation, delocation, and formation of the virtual machine. So the virtualization software look for that one. So in the resource pooling architecture, so whatever the computational resources majorly we have, it is being categorized into the these three categories: server category, storage category, and the network category. And the sufficient quantity of the physical resources of all three types are hence in the data centers. Basically, the customer basically demand about the server or the computational storage space or the network kind of the services. So either the storage services or the network services or the computing or the server services we typically may required in the market. So in the case of the server pools, composed of the multiple number of the physical server along with their own set of operating system, network capabilities, other necessary softwares already installed on it. And we have a multiple number of the servers. I have a multiple number of the servers. I am the cloud service provider. I have a multiple number of the servers, and these servers are being controlled by the VM. Each server having their own set of VM, and then we have a virtualization software, VMware software, virtualization software, and this particular software, the VMware software, looked at what is the need of the user, what is the need of the user, and accordingly it may select what are the resources may be granted to this particular user, and so on. That is being done by this virtualization software. So customer can choose virtual machine configuration from the available templates. Also, dedicated processor and the memory pools are created from the processor and etc. So server pool means a kind of the category where the customer required server, and the server having different configurations, like they may have different capacity of the memory, different capacity of the computational power, and so on. So as per the user requirement, a particular server is being assigned to the particular customer. Similarly, we have a storage pool. So we in the storage pool, we are basically looking for the data management and the protection of the data. So storage pools are composed of file-based system or the block-based system or the object-based system, depend upon that what kind of the request the data centers typically take. So file-based storage, block-based storage, and the object-based storage. These kind of the storage facilities are available. We talk about the network pools. So resources in the pools can be connected to the each other or to the resources from the pools by the network facility. So in that way, basically network pools composed of different networking devices like whatever the networking devices like your gateway, switches, router, etc. And VM then create from the physical networking devices and offer to the particular customer. Customer can further build their own network using these virtual networks. So whatever the network resources are there, that is being virtualized and that is being allocated to the particular customer as per their demand. We talk about the resource pool. Now we have a resources sharing. So resources sharing means we already have seen that the data centers may have a shared resources or the separate resources for each and every customer. However, nowadays all the mostly the data centers they go with the shared resources, because the shared resources help the data centers to share, share the unutilized resources to the new customer. So we have a multi-tenancy concept. So in the case of the multi-tenancy basically multi-tenancy means multiple number of the customers simultaneously working with your cloud service and cloud services. So multi-tenancy basically perform in the public clouds. So just like that, unlike the traditional single tenancy means you have a single customer and you are offering your entire hardware and the software to the single particular customer, and you are completing the task of the single customer. Then you are taking the next customer in the queue, and you allow it to work with their requirement. Similarly, if the second once the second customer will complete, you are moving to the third customer and so on. That is the single tenancy. One by one, you are allowing the user to uh, work with your resources. Whereas in the case of the multi-tenancy, simultaneously multiple number of the users are working with your uh, whatever the cloud service you are providing. So multi-tenancies leads to the sharing of the resources by the multiple user without the user being aware of it. User will never know that I have demanded I have created thousand number of the thousand number of the block from the 100 TB space. User required to suppose that some kind of the 1 GB of the space. So user will never know that how many number of the blocks are being assigned to the user, because user is a layman. If you if you basically devote the some technical glitches to the customer, layman customer, then definitely it is not feasible to handle by them. So that's why we need to go with the some kind of the resource management here. So multi-tenancy features enabled by the various features like your virtualization, resource sharing, dynamic allocation, resources pooling, etc. etc. So you can see here that we have one database or one application, and the one particular user gets the entire this hardware and the software is being allocated to the one particular customer. That is the single tenancy. This is allocated to someone else. This is allocated to the someone else. That is the single tenancy. This single tenancy having their own advantage and a disadvantage. We will come on that one. The another one is we have a multi-tenancy. In the case of the multi-tenancy, we are not partitioning, we are virtually partitioning. Here we have actual partition. We have created a one set of the resource, we have created the another set of the resource, physical resource, we have created the another set of physical resource. Whereas in the case of the multi-tenancy, we don't need to go with the number of physical resources. However, what we are doing here, we are partitioning the available physical resources into the number of users we have. So that is the multi-tenancy. Now, in the case of the multi-tenancy, we have a single tenancy or the multi-tenancy. In the single tenancy architecture, single instance of the application software along with supporting infrastructure is used to serve a single customer. So in the case of the single tenancy, one customer will come and the cloud is being served to the one particular customer. So obviously this will not this particular approach is not fruitful for the for your organization. Then what you may do, so in the case of the single tenancy, there is no sharing with this type of the tenancy and provides better security but cost more to the customer. Provide the better security because in the case of the single tenancy, you are the only single customer. So okay. So obviously, the resources are not being partitioned perfectly among the other customer. Then in that way, so in this one case, so security is obviously very high. So multi-tenancy can be implemented in a single multi-tenant database, one database per tenant, or one app instance to the one database per tenant. So just like that, either you have given one app to the one particular, or you have given the app and the database to the particular customer. So that is the multi-tenancy concept. Next, so tenancy at a different layer. So tenancy, whatever the kind of the services are being provided by the cloud, tenancy may be particular services. Tenancy may be of particular particular cases. So suppose that you are working with some giant organization, and so whatever the services the cloud service whatever the cloud platform provides us the services, that services the multi-tenancy of that particular service will become the tenancy at a different level of the cloud services. Just like that, multi-tenancy at the IaaS level, we already have seen about yesterday what is the IaaS. So multi-tenancy is at IaaS level, or the multi-tenancy is at a platform as a service model, or the multi-tenancy at a software as a service level, and so on. Now come to the another topic, that is the resource provisioning technology. So in the case of the resource pool, we have seen that we have a resource pool in the cloud computing. We have a resource pool, like we have a very high storage. Yes, we are high storage area. We have number of we have uh, number of the application. So in the case of the resource pool, we have a number of resources, the replica of the resource. So that is the resource pool. Now, the resource provisioning tells us that how many number of the resources is being allocated. How many number of the resources are there? Only one set of resources provided to you, or the 10 number of the resources you should be provided. That is the resource pool. Means how much number of the resources you require. So it can be a three types: static, dynamic, and the hybrid. As by the static approach, as by the name, static approach means it will declare that this much number of the processing power, this much number of the memory power I require. Simply, it may say that uh, how many number of the uh, how number of the resources required here. In the case of the static approach, before starting of the task, before starting of your operation, you should declare that how many number of the resources should be allocated to you. So accordingly, so in the case of the static approach, as per the customer demand, that much number of the resources are being allocated to the virtual machine, because we are working. So uh, I'm as a company owner, I will definitely go with the multi-tenancy approach. So particular only customer will be allocated to that particular resource. We are there. You in the beginning, before using of that particular resource, you have declared that how many number of the resources you require. That is the static approach, and there is no runtime. There is no runtime flex. The help or the no runtime something is being provided. So there is no runtime overhead. So in the case of the static approach, because you have declared that whatever the number of the resources you required, it should be ready in position before you started to use that one. So in that case, what will happen? Uh, in the case of the dynamic approach, if you think of also in the case of the static approach, we already have calculated what are the resources required, and accordingly we are going to allocate. So this is the static approach. You should have the replica of the resources, many number of the replica of the resources, because you will never know that how many number of the customers are coming at a point. Whereas in the case of the dynamic approach, during the execution of the program, if the program requires some more resources. So in the case of the dynamic approach, you must simply send the information to the cloud service provider, and the cloud service provider will verify you, and then they may allocate to the resources. So in the case of the dynamic approach, a runtime overhead is very high. Runtime overhead means you are communicating with the uh, different this service provider. Now, so you can see here that what is the disadvantage and the disadvantage of the static approach. So suppose that this is your actual need. This is your actual need, and this much number of the resources you have been allocated. So the some extra copy of the resources are being allocated to you, by assuming by the service provider that you may demand some extra number of the resources at any time. So if they are keeping the resources ready, so that as soon as the demand will arrive, they may allocate the resource to the particular customer. So in the case, so you can see here that this is the actual demands, this is the resources allocated, this much number of the resources allocated, and now during the execution of the program for this much amount of time, the system has asked about the some more instances of the resources. So this will fall under the category of under provisioning. If the resource demand is higher than the resource allocated, then the cloud computers is under provisioning. Whereas if the actual demand, if this is the actual demand, this is the these are the over provisioning, and this much number of the resources allocated. So suppose that in the case of the above, you are allocating to the resources you are allocating to the number of the resources to the customer. That is the static approach, and among the captured number of the resources by the customer, later on the customer asking for the more number of the resources, so that will become the under provisioning. Whereas in the case of the over provisioning, this is the actual demand, this is the actual demand, and this much number of the resources has been allocated. So your demand is less, and you have allocated lot of resources before actual starting of the work. That, so in this one case, what will happen? So you can see that for this much amount of time, only, these entire resources are under the utilization phase. So, all these resources are under the utilization phase. So this is known as the over provisioning. If the demand exceeds the resource allocated, then it is known as the under provisioning. So in the case of the over provisioning, you can see that for this much amount of time only, the most part of the resources has been utilized. Whereas before that and after that, you can see that it is required very less number of the resources, not a big number of the resources required here. So this is known as the over provisioning. Under provisioning means at the runtime you need more resources. Under provisioning means whatever over provisioning means uh, under provisioning means you requested for the extra amount of the resources during the runtime. Whereas in the case of the over provisioning means lot of resources are required in the beginning, and you still so obviously, so static approach having their own advantage and the disadvantage, and the dynamic approach having their own set of the advantage and the disadvantage. So completely completely either the under provisioning or the over provisioning cannot be eliminated. You have to bear with that one. So the another approach, we have a dynamic approach. In the case of the dynamic approach, so in the case of the static approach, what we have seen, if the in the case of the static approach, at the beginning the resources are being allocated to you, and during the execution of the program, if you feel that some more resources are required, you are allocating to the resources from the resource pool. That is the under provisioning. Whereas in the case of the over provisioning, what are the disadvantage of the static approach? Is the major disadvantage of the static approach is that in the future, if more number of the resources required, so definitely that resources may not be provided. Whereas in the case of the uh, over provisioning, lot of resources you already acquired before actual starting of the task, and during the execution of the task, you feel that most of the resources you have acquired without any purpose. That is the under provisioning. Sorry, over provisioning. So the another ISO over provisioning having the great disadvantage that most of the resources are idle, not in use. So the so which approach we should go? The under static approach or the dynamic static approach, the under provisioning approach or the over provisioning approach. The thing is that you cannot predict in the advance. You cannot predict that after 1 hour of the execution, the you are jumping into the under provisioning approach or the over provisioning situation. So that's why we have another kind of the approach that is known as the dynamic approach. In the case of the dynamic approach, what we need to do during the initial phase, we may allocate, suppose that 50% of the resources we may allocate, and if the customer acquiring utilizing the 30% of the resources, or 30 or the 40 or the 80% 80% of the allocated resources, then we may slightly increase that one. We may slightly increase the number of the resources. So the dynamic approach tells us that let us start the task, let us start the execution, let us start the resource allocation with few number of the basic resources, and later on always look about that how much utilization of the resources is there. If the utilization is going beyond the 60 or 70%, then we may allocate extra number of the resources. So in the case of the dynamic approach, so it is variable and depend upon that how much demand is there. So, so a static approach. So in the case of the static approach, we have in the case of the static approach, before starting of the task, we need to declare the number of the resources we required, and once the execution has been started, you cannot demand any kind of the resources. That is the static approach. And the static approach having major problem is the under provisioning or the over provisioning. Whereas in the case of the dynamic approach, in the case of the dynamic approach, you are starting with the less number of the resources, and later on you are asking for the uh, some more quantity of the resources. So in the case of the dynamic approach at the run, in the case of the dynamic approach at the run time, you have to calculate that how much extra number of the resources you required, and suppose that this calculation requires some amount of time, and your acquiring for the resources is very high, then definitely you have to wait. You have to wait till the more resources are going to be allocated to you in the case of the dynamic approach. So dynamic approach looks much better because it basically predicted how much number of the resources you require, and accordingly it allocate the resources. So wastage of the resources in the dynamic approach is less, whereas in the case of the static approach, wastage of the resources may be very high if you have been allocated a lot of resources. So both having their own advantage and the disadvantage. Whereas so we have taken the another concept, that is the hybrid approach, and in the case of the hybrid approach, we basically proceed in the beginning with the less number of the resources, and later on, as per the demand, we are or increasing or decreasing the allocated resources. So that is the hybrid approach. Next approach is VM switching. So just a minute. Just a minute. So next approach is VM switching. So in the case of the VM switching, basically it estimates the amount of the resources that a virtual machine should be allocated. We have seen, we have seen yesterday that a virtual machine is there, and the virtual machine is basically talking with the physical hardware. So virtual machine, so each and every hardware is being monitored by the virtual machine. You have created thousand number of the partition of a 100 TB hard disk. Then it means that you have created thousand number of the virtual machine. How many number of the virtual machine you should be given, it depend upon that how much number of the resources you have applied for, you have requested for. So the VM machine staging is the process of estimating the amount of the resources that a VM should be allocated, and its objective to make sure that VM capacity is kept proportionate to the workload. Whatever the workload are coming, so number of the VMs should be allocated. If the allocation of the VM should proportionate to the workload. So common type of the VM CG. So it is a fixed or the predefined CG. So in the case of the fixed or predefined CG, you are allocating a fixed amount of the virtual machine VMs to the particular customer. I so that is so in the case of very it is very similar. It is very simple approach that the fixed or the predefined seeding is a very simple approach, and in the beginning you are allocating fixed amount of the VM to the particular customer. So very simple. So advantage, and you can easily guess that what would be the merit and the demerit of this approach. Whereas in the case, so you can see here that the resources like CPU cores, memory, or the storage. So one particular VM having the some suppose that 8 number of the cores and 16 GB of the memory and the 1 TB of the storage. And the customer who is coming here, that need to calculate only that need to perform only a simple calculation, simple arithmetic calculation. Then there is a wastage of the memory and the storage here. So we have went with the custom stitching. So in the case of the custom stitching, the customers are allowed to customize the allocation of the resources according to the specific need. Now the customer will select how many number of the resources it the customer may require. So in the case of the customer will decide it how many cores, how many number of the memory space, how many number of the storage space it may be allocated. But there is a problem. So the custom staging is look better than the fixed staging approach. But the problem with the custom staging is that the customer should be technically sound to estimate that how many number of the resources the customer required. That is the one of the biggest challenge with the customer staging. Third one is the bustable staging. In the case of the bustable staging, the cloud environment offer a bustable performance, and these instances provide a baseline level of the resources with the ability to temporarily increase resources when the workloads demand permit. So slightly bustable staging means in the beginning you have bustable stitching, just like in the starting, that kind of the fixed stitching is there. So this much resources is allocating. However, there is a something different in the bustable stitching is that slightly you may increase or decrease slightly you may increase or the decrease the requirement of the resources depending upon the massive application or the storage focused task or the GPU accelerated workloads, the cloud service providers may tell you that this much is the optimum number of the resources, and this much number of the resources may fulfill your task. So that is the optimization of the specialized and the auto scaling. So auto scaling means you start with the some amount of the resources, and during the runtime, it observed that you require some more resources. So at the runtimes, you are providing more resources. After some amount of time, it has been observed that you require some more resources. So more resources is being allocated. So miss the allocation, de-allocation is varying at any rate is the auto scaling. So that is the resource allocation and the resource provisioning. So now come to the next unit. Unit resource provisioning. Resource provisioning we have seen that we have seen about the static resource provisioning, dynamic resource provisioning, and the hybrid resource provisioning. And the resource provisioning simply tells us that the requirement of the resources may vary depend upon that what kind of the uh, resource provisioning concept we follow. Now suppose that so we have seen that the resource provisioning means the resources are being allocated or de-allocated either at the beginning or at the product time. So now come to the scaling. Scaling is how much need to be scaled. Provisioning tell us that uh, I need some more resources. So my program is running on, my instruction or the task is running on, and suddenly the task tells that I need more resource, I need more resource. But how much amount of the resource should be allocated? That is the another question. My task is running and my task has raised a situation alarm that more resources required. So okay, it required more resources, but how much number of the more resources it may be given? There should be given a fixed number of the more resources, or there may be a variable number or the variation in the resource allocation. That is the scale. So So we have a two concept here: cloud elasticity and the scaling. So scalability refer to the flexibility of the allocation of the resources as per the demand, and the resources may be anything: CPU allocation, memory expansion, storage, network requirements, etc. We already have seen all these concepts. So so cloud elasticity basically refer that how it basically refer a property of the cloud that it grow or shrink capacity of the whatever the resources you may have. So cloud elasticity can be automatic without need to perform any capacity planning in advance, or it may be a manual process. Cloud elasticity, how much it should be elastic, how much it should be elastic, how much more resources may be granted, how much resources may be disallocated. So, so it is very. So we have a monitoring tools that offer by the cloud provider dynamically adjust the resource allocated to an organization without impacting the existing cloud-based operation. One more thing, in the cloud operation, you always have to monitor, you always have to monitor what is the current status of the customer. So customer program is running without any hassle, or the customer need some more resources, or customer has acquired some resources where the customer is not utilizing 100% of its resources. That need to be monitored, and dynamically you have to disallocate of the resources as per the customer requirement. So so here you can see that so importance of the cloud elasticity. So cloud elasticity having very much importance. It in term of the ongoing management of that capacity, including tasks like OS upgrades, patching, addressing component failures, etc., etc. So cloud elasticity means suppose that I have a five number of the VMs, and suppose that I have a 100 customers is running on 500 number of the VMs I have, and 100 number of the customer are presently working with my cloud, and some of the VMs are not working. Some of the VMs are not working. So immediately the new VMs will be allocated to the customer, existing customer, and so on. So this is kind of the elasticity. So elasticity acting as a vital tool for the businesses, preventing both over provisioning and the under provisioning. Because in the either it is the over provisioning or the under provisioning. If it is the under provisioning, then uh, under provisioning, and whatever number of the extra resources it required, suppose that amount of extra resources are not available to the cloud service provider, then what will happen? The performance will be either your task will be terminated or the performance will be degraded. Whereas in the case of the over provisioning, in the case of the over provisioning, most of the resources may be unutilized. So both having their own merit and demerit. So in the case of the how it does works, so cloud elasticity basically uh, swiftly adjusts their capacity automatically or manually by scaling up and the down concept. So how much need to scale up, how much need to be scaled down. So elasticity can be activated automatically, responding to the workload patterns initiated manually, often within the minutes. Very quickly, it basically estimate that how much elasticity is required here. So common use of cloud elasticity. it is it should be included. Suppose that just like Amazon, just take an example of the Amazon.com, the e-commerce at Amazon.com. So why the elasticity required? Because suppose that on day per day basis the Amazon work with the suppose that 1 million number of the orders. In a general day, Amazon receive 1 million number of the order, and the Amazon services the 1 million order. Now, at a some time, Amazon.com has announced a seasonal, some kind of the some kind of the uh, holiday periods, or the some kind of the offers. The Amazon has is declaring some kind of the special festive deals. The special festive deals or the Black Friday kind of the concept. Amazon has declared that from this date to this date, a Black Friday deals will be there, or the festive deals will be there. The items will be on more cheaper rate or more discounted rate. So during that period of the times, suddenly the Amazon who are working with the 1 million of the orders, it may be suddenly during that period of times the Amazon receive 5 million number of the orders. 5 million orders the Amazon may receive at a particular time. So the Amazon is working with the 1 million orders, and suddenly the spike for the 5 million orders, 5 millions of the orders. So you can see here that that should be that should be manageable. By that should be manageable and predictive. The Amazon should predict this much number of the spike before starting of the this kind of the uh, good offer. Otherwise, what will happen? The server will get it down, and the Amazon may not be available to serve the customer. So seasonal spikes. So elasticity should be required to estimate the seasonal to service the seasonal spike, peaks in the demand during the some other kind of the events like school district registration. So new season is being started. So all the students need to purchase a book. Sorry, a kind of the peak demands. Business expansion sudden surge due to the product launches or the viral social media attention, etc. Utilizing public cloud capabilities due to some disaster recovery or the business continuity, scaling virtual desktop infrastructure in the cloud for the temporary workers, contacts, etc. Temporary scaling, adapting to the unplanned projects or the temporary initiative like batch processing or the media rendering, etc. etc. So these are the uses of the cloud's elasticity. Now, advantage of the cloud's elasticity. It provides us the flexibility. So and it basically also allow us the usage based on base pricing and the high availability, efficiency, and the accelerated time to the market. So so the cloud so this cloud elasticity having lot of advantage. So we have seen here the advantage about the what what refers the terms flexibility, usage based pricing, etc. etc. So scaling primitives basically exploit the elastic property of the cloud, which we have studied in the earlier section, and the scalability of the cloud architecture is using the virtualization. We already have seen, and the virtualization using the virtual machine for enhancing or reducing the computing power. Whatever the number of the resources required there, enhance the resources or the reduce resources, etc. etc. So key advantage of the cloud scaling, minimum cost. So user have to pay a minimum cost for the excess usage of the hardware after the upscaling. Similarly, ease of the use, flexibility. User have to flexible to enable disable the certain VMs for the app scaling and the down scaling. Recovery, the cloud environment itself reduce the chances of the disaster and amplify the recovery information, etc. stored in the cloud. So recovery is also very easy. It's provide a flexibility environment and ease of the use environment. And the one of the major thing is the minimum cost. You have to start with the minimum cost. You should not need to purchase the 100 TV in the beginning. You may start with the 1 TV. Later on, you have you later on after 5 days or after the 5 months, you observe that you need two more TV space, 2 TV more space. So you may consult with your service provider, and you may the service provider may provide you the 2 TV more space too. So you are so in the beginning stage you have paid only for the 1 TV. Later on you observe that you require two more TV here. So accordingly you are starting with the minimum cost, and accordingly you are proceeding further on. Whereas in the case of the fixed approach, if the cloud elasticity approach is not there, just like a fixed sieging approach, in the beginning you are going to procure 200 TB space, and later on you have observed that after the 5 months you have only used 2 TB of the space or the 3 TB of the space. So you are paying higher there. So that is the problem. So so in the case of the manual scaling, so we fixing the checkpoints, the workloads, and accordingly you are deciding about the more resources here. And similarly the accordingly the cost is going up. Whereas in the case of the semi-automatic, you already have set up the some benchmarks. As soon as you are in the under provisioning space, it is being allocated, and so on. So in the case of the manual scaling, manually you have to observe about the under provisioning or the over provisioning circumstances, and accordingly you need to go for the resource allocation. Whereas in the case of the semi-automatic scaling, you already the under provisioning or the over provisioning is being monitored, and accordingly the resource allocation is being done automatically. So scaling, if you talk about the scaling strategies, so we have a proactive scaling. Proactive scaling means the situation, the proactive scaling pre-scheduled according to the expected traffic and the demand. So in the beginning, the proactive scaling tells us that proactive scaling means we need some certain amount of resources, we either before starting of the job or after starting of the job. So scaling simply once again understand the word scaling. Scaling means you have started with some fixed number of the resources. Later on, you observe that you need more resources. How many number of the more? How much number of the more resources? So let us suppose that say five number of the more resources. So, so it may be allocated to the five number of the resources. After sometimes you require 20 number of the more resources. So the scaling means scaling part by part, not you are scaling 100 at a once. That need to be specified that how much workload is increasing, accordingly how many number of the scaling required. So that is the proactive scaling. Proactive scaling basically tells us that you should increase the number of the resources in a certain amount as per the workload demand. So you can see here that the productive scaling, as soon as the load is increasing, resource allocation is going in a some pretty fixed, pretty decided manner. Whereas in the case of the reactive scaling, so in the case of the in the case of the productive scaling, whatever the workload is there, you are allocating a fixed number of the resources at each stage. That is the proactive scaling. Means before starting of the task, you already have did some kind of the calculation to decide that how many number of the resources should be allocated once the workload is going to increase. So uh, there is no certain relationship between the workloads and the scaling formula. So definitely that is not acceptable in case of very high demand of the very high fluctuating rate of the workloads. The proactive scaling is not feasible in terms when the workloads are workload having a very high spike, very high fluctuation. Whereas in the case of the reactive scaling, in the case of the reactive scaling, you need to first analysis that how much workload is there, and accordingly how much scaling is required, and accordingly you are calculating and you are scaling up or the scaling down as per the workload. So it is a reactive, and we have a combination. So obviously the proactive is also not uh, good for every time, and reactive having their own set of calculation cost or the algorithmic cost. So that is also not feasible every time. So we are going with the combinational scaling. In the case of the combinational scaling, we are starting with the proactive scaling concept, and later on we move to the reactive scaling concept. So if we see the comparison between the proactive scaling and the reactive scaling, you can see here that suitability. So for application increasing loads in expected or the known number, then we may go with the proactive scaling. Not a sudden spike in the load, then we may go with the proactive scaling. Whereas in the reactive scaling, if the application increase the load in the unexpected or unknown manner, sudden spike in the workload, sudden lot of workloads are there, and after few minutes or the few hours, minimum workload is there. So in that one case, we may go with the reactive scaling. Whereas the workload is expected means you can predict that how much workload is going in the next 2 hours, then you can go with the reactive scaling. Working you just set the threshold, but a downtime is required because you need to set the threshold for that amount of time for the calculation, for the prediction, for the calculation. You require some kind of the downtime so that you may set the new checkpoints. Whereas in the case of the reactive, you use a defined threshold value, optimize the resources. Cost reduction, in the case of the productive, it is a minimum cost reduction. Reactive is also medium cost reduction. Implementation, in the case of the proactive scaling, few steps required because lot of things you already have predicted earlier, and accordingly you are setting the checkpoints. Whereas in the case of the reactive scaling, fixed number of the steps required, fixed number of the steps required here, because you do not need to you just have to correlate with the workloads, and accordingly you have to calculate and you have to allocate. So that is the end of your unit 3. Now sorry, unit 5. So now let us see auto scaling. So we have seen proactive scaling and the reactive scaling, both are the kind of manual scaling. Now come to the auto scaling. So in the case of, just I'm quickly coming to the numerical part of here. So auto scaling basically means how much scaling up required, or the how means in which ratio the scaling up or the scaling down required. That is the auto scaling. So in the case of the auto scaling, we need to consider two parameters here. The first parameter is the number of the instances required to scale, and the number two, absolute number or the percentage of the current capacity. So auto scaling means depend upon the workload, depend upon the increasing or decreasing workload, we need to estimate the number of the instances required to scale. That is the auto scale. So you can see here that this is the workload, this is the workload, and this is the workload. As soon as the workload is being increased, uh, scaling up is being done. The workload is increasing, the scaling up is being done. The workload is increasing, scaling up is being done. The workload is now decreasing, the scaling down is being done. So this is the automatically scaling in the cloud environment. So just like that, why the auto scaling required? Because you can see here that for the e-commerce websites, you can see here that it may having this requirement is high for the sometimes like holidays, weekends, etc. At these times, the e-commerce may having the larger workloads, larger visit of the customer. So accordingly, we may copy. Whereas for the case of the Monday or the Tuesday working days, it may having a very less work. So the cloud will automatically calculate and scale up and scale down of the resources. So the auto scaling will be more beneficial here. So the auto scaling depend upon the service level agreements, and these agreements each specifying the uptime percentage, response times, support availability, establishing benchmarks, etc. etc. So service level agreement is being done between the parties, the customer, the cloud customer and the cloud service provider, that when the customer require the or which kind of the scaling required, auto scaling or the predictive scaling or the reactive scaling, and accordingly the pricing is being done. So a scale-up process required to satisfy the following property: the number of the incoming requests per second per node, threshold value, and thereafter we need to scale up. Similarly, the number of the incoming requests per second per node is less than the threshold value, then we may go with the scale down. So in the service level agreements, we may in the SLA we may set some kind of the threshold, and accordingly scale up or the scale down is going on depending upon that what is the number of the request per amount of time. So in the case of the fixed amount of auto scaling, just I'm showing you that suppose that uh, this is you see here that 50% of the resources and the scaling up is required. So how much number of the resources you need to increase here? So as per the SLA, we may calculate here, and accordingly you may decide about the, so the threshold is greater than the threshold is in, so request per second is greater than the threshold, then you are allocating, you are going for the scaling up. Whereas request per second is less than the threshold, then you are going for the scale down. So you can see here that so present allocation is 4 and the request per second is 450. You have calculated request per second, and you are working with the current allocated board. Now later on you have seen that your request per second is increasing. Now you are calculating how much number of the how much number of the resource required by this particular steps. So you can see here that two number of the resources required. So two more scaling up you are doing, and now the total scaling up is 6. Later on, more requests per second is arriving. Again, you are going with the two scale up. So you are going with the here it is showing the example of fixed scaling up. Every time every time the node is being added 2 into the quantity. As per the increasing number of the requests per second, every time you are allocating 2 number of the more resources. So that is the scaling. So that is the scaling up, and now thereafter uh, so you can see here that RPS is increasing on, request per second is increasing on, and the resource scaling up is going in the fixed manner. Now after some certain times, you can see here that the RPS is going to decrease, request per second is going to decrease. So you are reducing the scaling down. You are scaling down the number of the resources to to scaling per unit of time. So you can see here that you are increasing as well as decreasing. So that is the fixed amount of scaling up or the scaling down. So you can see here that there you can see here that 450 to 1800, near about 1400, near about 1450 requests per second is increasing on. You have allocated two number of the resource allocation here, whereas you can see that only 700 increasing, 700 has been increased, still you are scaling up by the 2 unit. So means there is no correlation between the request per second and the number of the nodes would be allocated. This is in the case of the fixed scaling up concept. So sometimes you may have a very large workloads, sometimes very large number of the RPS difference, or sometimes you may have a very less RPS difference. But you always increasing or decreasing, scaling up or downing by the 2 units only. So that is not obvious. That is not obvious because always has in the sudden spike of the demands you have scale only two, whereas after sometimes a few scaling up is there and you have allocated again two. So that is not uh, uh, that may lead to the performance degradation. So we have another method, that is the percentage method, percentage scaling. So here we take a relationship between the threshold and how much number of the RPS is coming on, and depend upon that we basically calculate how much percentage number, how much scaling up required, not a fixed scaling. So you can see here that here the example here the example is again going with the one. So in the case of the percentage, so for this particular example, only the single percentage is going on. But you can see here that by the case of the percentage scaling, uh, we basically observe the relationship between the request per second and the number of the nodes allocation per unit of time, scaling up or the scaling down. So you can easily calculate here based on the percentage of the RPS. So this is the scaling up. So type of the scaling, it may be a vertical scaling. Vertical scaling is currently you have a two number of the resources and you require four number of the resources. So vertical scaling here. Horizontal scaling is, so this is the servers, means you the number of the CPU, number of the memory, number of the storage here, and you have requested for the horizontal scaling means currently you have only one and you have demanded for the two. You have demanded for the two. So two means the so this is the one set of one. This is the one set of the resources. Now two set of the resources means at the same time two servers, two CPUs, two times CPUs, two times storage space required. Means in the case of the vertical scaling, one particular resources is being increased. One particular resources is being increased as per the demand. Whereas in the case of the horizontal scaling, you are increasing multiple number of the resources at a time. So one server is there. Now you require two number of the server. Two number of the server means at the same times two times CPU, two times storage, two times memory required. Three three number of the servers required. So at the same time, three times of the processor, three times of the memory, three times of the storage is being increased. So that is the horizontal scale. So that is the end of your this unit, and Load balancing. Now come to the load balance. So we have seen about the cloud elasticity and the scaling, which is important characteristic for the cloud. And now we will focus on the another aspect of the load balancing. So in the case of the load balancing, the distribution of the incoming network traffic across the multiple server or the resources in the cloud. In the case of the scaling up or the scaling down, we are basically scaling up or the scaling down the number of the resources required. Now, the load balancing basically look at whatever the incoming number of the traffics are there, that traffic should be diverted to the virtual which particular VMs. If a set of VM is less, a set of VM having a less traffic, and the set of VMs having a very high traffic, then we may shift the load from the highly utilizing VMs to the lesser utilizing virtual machine. That is the load balance. Load balance means number of the incoming traffics, not the request. Request is something else, traffic is something else. Network traffic means how much number of the user are increasing. That is the load. There you require a load balancing. How many number of the user are increasing? That is the load balancing. How much? How many number of the resources required by the user is increasing or decreasing? That basically refer to the scaling. So balancing and the scaling are the two different terms here. So, so let us see in the case of the load balancing. So load balancing is also required because suppose that one particular server is there, and most of the traffics are being diverted to the one particular server. Then this server will be very busy, and suppose that there is no traffic to this particular server, so this server is underutilization. It is in the this server is in the case of the overutilization. This server is under the case of the underutilization. So definitely this need to be balanced so that all the resources should be utilized in a proper manner. No resources should be in the case of the underutilized or in the idle case. So, why it is required the load balancing for the optimized performance, overall optimized performance, system performance by providing a smooth and the consistent user experience. A load balancing required, high availability and the reliability, multiple servers or the regions. So if the so in the case suppose that why the load balancing required, suppose that this server was heavily utilized, and suddenly it is going to be failure. So what it to this different. So high availability and the reliability. So you may observe, and if one server fails or experiences some issue, traffic can be directed to the another server. Scalability and the flexibility. So load balancing, dynamic resource allocation, and allow for the easy scaling, enabling the addition or the removal of the resources based on the demand. So scalability and the flexibility is being provided by the load balancing. Similarly, the cost efficient will be there. The load balancing also help us in the case of the fault tolerance and the resilience, and it support the modern architecture. So load balancing. So load balancing works based on the traffic distribution. Some kind of the load balancing algorithms are there, just like that. Round robin methods are there, least connection methods are there, weighted round robin methods are there. What is these methods? How these methods works? This is the beyond the scope of the discussion here. But you just assume here that load balancing is being monitored by the some kind of the algorithm. Health monitoring, just health monitoring of your resources, of your servers, session persistence, so maintaining the session. So load balancer can employ techniques like cookie base or IP base. If if the packet is coming from this particular IP, this pool of IP transfer to the load balancer system. So scalability and the elasticity is provide, and the availability, content delivery, and the security basically, uh, the load balancing help us to perform. So that is the end of your. So we have, uh, if we see about the type of the load balancer, we have a software load balancer, hardware load balancer, and the virtual load balancer. So by the name, you can easily understand that the software load balancer means the a kind of the software which basically calculate and basically deploy the load balancing terms. Whereas in the case of the hardware load balancer means we have set up extra hardwares with our system to estimate to predict the load balancing task. Whereas in the case of the virtual load balancer, it is a combination of both soft. It is a combination of the software and the hardware. So load balancing algorithms, we have a static load balancing algorithms, just like your round robin is load balancing, fixed kind of the load balancing based on the some kind of the fixed terms like weighted, round robin, etc. Based on the IP addresses, based on the opportunistic algorithms, min algorithms, max min algorithms, etc. etc. If you have some kind of the idea about the min algorithm or the min max algorithm from the artificial intelligence paper, so you can easily correlate here. Similarly, in the case of the dynamic load balancing, based on the certain circumstances like this list connection, weighted response times, it calculate the load balancing where the traffic should be diverted. So this is about your all about the load balancing. So now this time is over. So now the session is open for the question answer. If anyone having any question or doubt, you may please put up here. We may discuss. If anyone having any question or any doubt in any of the topic we have discussed yesterday or within the last 3 days, you may put up here. This is your third session, so you may ask question from we have discussed either in the first session or in the second session or in the third session. So now this session is open for the question answer doubt. You may please ask the question or the doubts you may have. Either you unmute yourself and put your question, or you may type your question in the chat box. Okay, so there is no questions is coming from the side. So okay, so this is okay. Okay, so no more questions is here, no more doubts is here. So this is the end of today's session. This is the end of today's session. We will meet tomorrow at a scheduled time for the next session. And tomorrow we will start with the another block, that is the Internet of Things. Thank you everyone.
Thank you, sir.
Thank you very much.